calculation for determining the appropriate wire size for the described installation is as follows. Firstly, determine the amperage of each water heater. With a power of 3,500 watts and a voltage of 120 volts, the current draw for each heater is calculated by dividing the power by the voltage. This results in 29.16 amps per heater. Secondly, apply the 125% rule for continuous loads. According to the National Electrical Code, continuous loads, defined as loads operating for 3 hours or more, require the circuit to be rated for 125% of the load. Multiplying the 29.16 amps by 1.25 results in 36.45 amps. This is the minimum ampacity required for the conductors feeding each water heater. Thirdly, consider the conductor ampacity and overcurrent protection. The question mentions using number 10 THHN copper wire. However, according to NEC Table 310.15b16, number 10 THHN copper wire typically has an ampacity of 30 amps. NEC Section 240.4d restricts the overcurrent protection for number 10 copper wire to 30 amps, unless specific exceptions apply, which do not seem to be present in this case. Therefore, number 10 THHN is not sufficient. Number 8 THHN copper wire, which has an ampacity of 55 amps, is suggested. The number 8 THHN wire is suitable for the calculated load of 36.45 amps. Fourthly, select the appropriate overcurrent protection device. While the number 8 THHN wire can handle 55 amps, it is protected by a 40 amp circuit breaker. This is acceptable because the breaker rating is greater than the calculated load of 36.45 amps but does not exceed the ampacity of the wire. Fifthly, address the equipment grounding conductor EGC. The question mentions using number 10 EGC based on NEC section 250.122. This section provides guidelines for sizing equipment grounding conductors based on the rating of the overcurrent protective device. For a 40 amp overcurrent device, number 10 copper wire is indeed an appropriate size for the EGC as specified in Table 250.122. Sixthly, explain the multi-wire branch circuit configuration. The use of a multi-wire branch circuit consisting of 2 hot legs, phase A and phase B, and a shared neutral conductor is described. This configuration allows for 2 120-volt circuits to be supplied from a 240-volt source, sharing the neutral conductor. It is important to note that the neutral conductor carries only the unbalanced current between the 2 hot legs. In the scenario where both water heaters draw the same current, the neutral current is theoretically zero. Seventhly, emphasize the importance of a common trip breaker. A dual-pole circuit breaker with a handle tie is mentioned. This is crucial for multi-wire branch circuits to ensure that both hot legs are disconnected simultaneously in the event of an overcurrent or fault. This is a safety requirement outlined in NEC section 210.4b. Eighthly, discuss the popularity and applications of multi-wire branch circuits. The answer correctly notes that multi-wire branch circuits are not very popular, but they are used in some commercial buildings where space is at a premium. They can be beneficial in situations where a large number of circuits are required in a limited space, as they reduce the number of neutral conductors needed. Ninthly, calculate the total load on the panel. The total load of the 2 water heaters is 7,000 watts at 240 volts since they are on opposite phases. This equates to approximately 29.16 amps at 240 volts. The panel needs to be rated to handle this additional load. Tenthly, consider voltage drop. While not explicitly mentioned in the original question, voltage drop is an important factor to consider in any electrical installation. Excessive voltage drop can cause appliances to malfunction and can even damage equipment. The length of the circuit should be considered when selecting the conductor size to ensure that the voltage drop remains within acceptable limits, typically 3% for branch circuits. 11thly, consider the ambient temperature. The ampacity of conductors is based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is high, the conductor ampacity must be derated according to NEC Table 310.15 B2. 12th, consider conduit fill. If the conductors are installed in conduit, the conduit fill requirements outlined in Chapter 9 of the NEC must be followed. The number of conductors allowed in a conduit depends on the size of the conduit and the type of conductors. 13th, explain the grounding requirements. The equipment grounding conductor EGC is essential for providing a low impedance path for fault current to return to the source, which helps to trap the overcurrent protective device and clear the fault. The EGC must be properly connected to the equipment grounding terminals of the water heaters and to the grounding system of the building. 14th, discuss the importance of proper connections. All electrical connections must be made properly using approved connectors and methods. Loose or corroded connections can cause overheating and can lead to fires. 15th, remind about the importance of electrical safety. Working with electricity can be dangerous. It is important to always follow safe work practices and to de-energize circuits before working on them. If not qualified, consult a licensed electrician for electrical work. 16th, highlight the use of THHN wire. THHN wire is commonly used in electrical installations because it is heat resistant, moisture resistant, and flame retardant. It is suitable for use in dry and damp locations. 17th, explain the importance of the junction box. The junction box serves as a central location for connecting the multi-wire branch circuit to the individual circuits feeding the water heaters. It must be sized appropriately to accommodate all of the conductors and connections. 18th, discuss the balanced load. In a perfectly balanced multi-wire branch circuit, the neutral conductor carries no current. However, in reality, the loads are rarely perfectly balanced. Therefore, the neutral conductor must be sized to carry the maximum possible unbalanced current. 19th, emphasize the importance of the handle tie. The handle tie on the dual-pole circuit breaker ensures that both hot legs are disconnected simultaneously in the event of a fault. This prevents a situation where one leg is de-energized while the other leg remains energized, which can be dangerous. 20th, mention the potential for energy savings. Multi-wire branch circuits can potentially save energy by reducing the number of conductors needed. This can result in low material costs and reduced energy losses. 21st, advise on local electrical codes. Electrical codes can vary from jurisdiction to jurisdiction. It is important to consult the local electrical codes to ensure that the installation complies with all applicable requirements. 22nd, discuss the inspection process. Electrical installations are typically subject to inspection by a qualified electrical inspector. The inspector will verify that the installation complies with all applicable codes and standards. 23rd, highlight the benefits of using a licensed electrician. A licensed electrician has the knowledge and experience to safely and correctly install electrical wiring. Hiring a licensed electrician can help to ensure that the installation is safe and compliant with all applicable codes. 24th, discuss the troubleshooting of multi-wire branch circuits. Troubleshooting multi-wire branch circuits can be more complex than troubleshooting simple circuits. It is important to have a good understanding of how multi-wire branch circuits work in order to properly diagnose and repair problems. 25th, discuss the use of SI and GFCI protection. Depending on the local electrical codes, arc fault circuit interrupter and ground fault circuit interrupter protection may be required for certain circuits. It is important to consult the local electrical codes to determine the specific requirements for SI and GFCI protection. 26th, review conductor identification. Conductors must be properly identified according to NEC requirements. Typically, the hot conductors are identified with black or red tape, the neutral conductor is identified with white or grey tape, and the equipment grounding conductor is identified with green tape. 27th, summarize the key points. In summary, when installing two 120 volt, 3500 watt water heaters using a multi-wire branch circuit, it is important to calculate the amperage of each heater. Apply the 125% rule for continuous loads. Select the appropriate conductor size and overcurrent protection device. Size the equipment grounding conductor. Use a dual pole circuit breaker with a handle tie, and follow all applicable electrical codes and standards. Multi-wire branch circuits are not very popular, but they can be useful in some situations where space is at a premium.